Welcome to this lesson on the International System of Units, commonly known as the C-unit system. Every day, we measure different physical quantities. We measure length, mass, time, temperature, speed, energy, and many other quantities. However, measurements are only useful when everyone understands and uses the same units. For this reason, scientists developed a standard system of measurement called the International System of Units. In this video, we will study the 7 C base units, derived units, C prefixes, unit conversion, and some important rules for writing units correctly. Suppose one person measures the length of a room in meters, another measures it in feet, and another uses an unfamiliar local unit. Although all three people are measuring the same room, comparing their results would be difficult. A standard unit system solves this problem. The C system allows scientists, engineers, students, manufacturers, and researchers throughout the world to communicate measurements accurately. Every physical quantity contains two parts, a numerical value and a unit. For example, in 5 meters, 5 is the numerical value, and the meter is the unit. Therefore, a physical quantity may be written as numerical value multiplied by unit. Without the unit, the number alone does not completely describe the measurement. Physical quantities in the C system can be divided into two main categories. The first category is called base quantities. Base quantities are independent quantities used to construct the measurement system. The second category is called derived quantities. Derived quantities are obtained by combining two or more base quantities mathematically. The C system contains 7 base quantities and 7 corresponding base units. The first base quantity is length. The C base unit of length is the meter, with the symbol m. Length measures the distance between 2 points. Examples include the length of a table, the height of a building, and the distance between two cities. 1 meter is equal to 100 centimeters, and 1 meter is equal to 1000 millimeters. The second base quantity is mass. The C base unit of mass is the kilogram, with the symbol kg. Mass represents the amount of matter in an object, and its resistance to acceleration. 1 kilogram is equal to 1000 grams. Mass should not be confused with weight. Mass is measured in kilograms, but weight is a force, and is measured in newtons. The third base quantity is time. The C base unit of time is the second, represented by the symbol s. Time describes the duration of an event. 1 minute is equal to 60 seconds, and 1 hour is equal to 3600 seconds. The fourth base quantity is electric current. The C base unit of electric current is the ampere, represented by the symbol A. Electric current describes the rate at which electric charge moves through a conductor. It is normally measured using an ammeter. The fifth base quantity is thermodynamic temperature. Its C base unit is the Kelvin, represented by the capital symbol K. The relation between the Celsius and Kelvin temperature scales is T in Kelvin equals T in degrees Celsius plus 273.15. For example, 0 degrees Celsius is equal to 273.15 Kelvin. The degree symbol is not used with Kelvin. We write 300 Kelvin, not 300 degrees Kelvin. The sixth base quantity is the amount of substance. Its C base unit is the mole, represented by the symbol mol. 1 mole contains exactly 6.022140076 times 10 to the power 23 specified particles. These particles may be atoms, molecules, ions, electrons, or other elementary entities. The mole is used extensively in chemistry. The seventh base quantity is luminous intensity. Its C base unit is the candela, represented by the symbol CD. Luminous intensity describes how much visible light is emitted in a particular direction. The candela is used in lighting technology, optical engineering, and photography. Let us summarize the 7 base quantities. Length is measured in meters. Mass is measured in kilograms. Time is measured in seconds. Electric current is measured in amperes. Temperature is measured in Kelvin. Amount of substance is measured in moles. Luminous intensity is measured in candela. These 7 units form the foundation of the complete C system. Derived quantities are obtained by combining base quantities. Consider speed. Speed is distance divided by time. Because distance is measured in meters, and time is measured in seconds, the C unit of speed is meter per second. Acceleration is the rate of change of velocity. Its C unit is meter per second squared. Force is defined using Newton's second law. F equals ma. The C unit of mass is the kilogram, and the C unit of acceleration is meter per second squared. Therefore, the C unit of force is kilogram meter per second squared. This combination is given the special name Newton. 1 Newton is equal to 1 kilogram meter per second squared. Energy is measured in joules. Work is defined as force multiplied by displacement. Therefore, 1 joule is equal to 1 Newton meter, or 1 kilogram meter squared per second squared. Power is the energy transferred per unit time. Its C unit is the watt. 1 watt is equal to 1 joule per second. Pressure is force divided by area. Its C unit is the pascal. 1 pascal is equal to 1 Newton per square meter. Some quantities are extremely large, while others are extremely small. C prefixes are used to represent powers of 10 and avoid writing many zeros. The prefix kilo, with the symbol K, represents 10 to the power 3. 1 kilometer is equal to 1000 meters. The prefix centi means 10 to the power minus 2. 1 centimeter is equal to 10 to the power minus 2 meters. The prefix milli means 10 to the power minus 3. 1 millimeter is equal to 10 to the power minus 3 meters. The prefix micro means 10 to the power minus 6. 1 microsecond is equal to 10 to the power minus 6 seconds. The prefix nano means 10 to the power minus 9. 1 nanometer is equal to 10 to the power minus 9 meters. Uppercase and lowercase symbols must be used carefully. For example, uppercase m represents mega, or 10 to the power 6, while lowercase m represents milli, or 10 to the power minus 3. Let us convert 72 kilometers per hour into meters per second. We begin with 72 kilometers per hour. We use 1 kilometer equals 1000 meters, and 1 hour equals 3600 seconds. Therefore, 72 kilometers per hour is multiplied by 1000 meters per kilometer and by 1 hour per 3600 seconds. The kilometer and hour units cancel. This gives 72 multiplied by 1000 divided by 3600, which is equal to 20. Therefore, 72 kilometers per hour is equal to 20 meters per second. When writing C units, several rules should be followed. First, leave a space between the numerical value and the unit symbol. Write 20 meters with a space between the number and the symbol. Second, unit symbols do not have plural forms. We write 10 kg, not 10 kgs. Third, symbols named after scientists begin with capital letters. Examples include N, J, W, and PA. However, when their full names are written, they normally begin with lowercase letters. Newton, joule, watt, and pascal. Units must also be included throughout scientific calculations because they help verify dimensional consistency. The International System of Units provides a universal language for measurement. It is based on 7 base units: the meter, kilogram, second, ampere, Kelvin, mole, and candela. Derived units, such as the Newton, joule, watt, and pascal are constructed from these base units. C prefixes allow large and small quantities to be written conveniently. Correct use of C units improves accuracy, prevents confusion, and makes scientific communication possible throughout the world. Thank you for watching.